All right, I've got some questions. I've had some questions on numerics, problems 8 and 9. Here is the table for worksheet 4. All right, I filled out this table. Let me see. Okay, I'm not going to go over everything for 8 and 9. I'll leave some of the parts for you to figure out. You're welcome. But let me just show you kind of how I figured out the things in the table. All right, so e to the whatever, remember this is 1 plus 1 plus 1 plus squared over 2 factorial plus I'm sure that's correct, but I just want to make sure I don't tell you wrong here, because that would not be good. But I do know this is true. E to the x, where are you at? There you go. You got 1 plus x squared over 2 x squared. Yeah. Okay. All right. Okay, so the way I filled in the table, let's see. Okay, so notice this thing is, this will come up later when we talk about step size a little bit, because that's there's been a number of questions on step size. All right, so this thing is centered at 0. So the centered at c equals 0. Right, remember in your Taylor polynomials you have the c. So here centered at 0, and then we have the center point and the evaluation point. Okay, the evaluation point is the number you put in here, right? So this is the evaluation point there, that's the evaluation point, that's the evaluation point. Evaluation point, evaluation point. Okay. So so for this, let's see, for like this row right here, right, this you could put in 1.0. Let's see, to go up to the degree 2, so what I did was I, in the Desmos graphing calculator website, I just put this whole thing in there, and then I put it in there with parentheses there, like that, just like that, and then I put in, well, okay, this one's already done for you in the table, right? So let's say I was going to figure out this row here. So you put in 0.5, 0.5, 0, 0, 0, 0, 0, 0, and that'll tell you your approximation up to degree 2. That number is that right there. This number is that right there. Okay, then 0.5, then that number is exactly that number right there. Right? That comes out to that. Then you do that again, and that takes you out to there, right? And then do that again. That takes you out to the 5th one, there, and so on. Okay, so that's how I filled in the stuff in the table. You might want to do that just to get a little practice, see what's going on there. Okay, only do one little part in problem 8. That is part C. It says, what is the step size? Okay, so from worksheet 4, page 133, the step size is the distance between the center point and the evaluation point. Okay, so this is the evaluation point. This is part C. The evaluation point changes for each of these rows. The evaluation point for this row is 1. The evaluation point for this row is that, 0.5. Evaluation point for this row is 0.2. Okay. All right, so what is the difference between the center point, or the distance? Yes. The distance between the center point, which is 0, this is c equals 0, and x equals 0.5. How far do you have to go from here to here, right? It's about half a mile, maybe to meridian or something, right? So how far do you have to go? 0.5. That's it. That's the step size. A way that you can always tell that is you can use, so you're trying to find this distance here. This distance, notice that this is 0.5 minus 0. If you put it in absolute value, it'd always be positive, so that's that distance. Okay. All right. So I'm going to add another column to this table. It's going to be a step size column. Okay, remember, step size is the distance between the center point. The center point won't change for any of these. That's given at the very top of page 133. All questions use Taylor polynomials for e to the x centered at x equals 0. I don't know why they put x equals 0. We've always used c for the center. Let's centered at c equals 0. Okay. All right. So the difference, you measure distance using a difference, a subtraction. But anyway, the distance from between the center point 0 and the evaluation point, that's 1.0. Right here, it's 0.5. Here, 0.2. Here, 0.1. Here, 0.05. Okay, so adding this column, I think, really helps solve everything there. Okay. Oh, all right. Okay, so now problem 9, I'm going to answer B, C, and D. Okay, B, C, and D. Okay, so in part B, so let's look at part B. Let's see, suppose you're required to use a step size 0.2. Okay, let's see, that was 0.2, it's right there. I guess these are 0.1, 0.05. Okay, so let's see, we're supposed to use a step size of 0.2. Okay, that puts us in this row. What's the smallest degree that will give you 4 decimal places of accuracy? Okay, so let's see, 0.2. Okay, 0.2, 4 decimal places of accuracy. Right here, there's 2 decimal places, right? 3 decimal places, 4 decimal places. Okay, the answer is 4. Do you see that? So step size of 2. Make sure you understand what we're talking about step size there. There. Go over to 4 decimal places. Right, there's 3. 1, 2, 3. There's 1, 2, 3, 4. 4. That started at degree 4. That's your answer there. Okay, C. Okay, right. Suppose that you are required to use a step size of 0.5. Step size 0.5 right there. But you are allowed to select any degree less than or equal to 4. So anything over this way. What's the best approximation you can get? Okay, let's see. Well, think about it, right? The approximations get better. So the bigger the degree you have. So let's see, 484. So here we're getting So degree 4 is the best answer there. What are you doing back there? All right, so let's see. Suppose that you're required to use step size 0.5, but you're allowed to select any degree less than or equal to 4. Any degree less than or equal to 4, so over here, right? The approximations are getting better as we move this way, right? So 4 is the best choice, right? 4 is a better approximation than 3. What's the error in that approximation? Okay, so that's D. What is the error in that approximation? That is, what's the difference between your answer above and the best possible? What's the best possible approximation you can get? Okay, so sorry, the answer to C is not 4, right? 4 is the best. Is the best degree less than or equal to 4, where you get the best approximation. So the best approximation you can get is is the one that we're using for, 1.6484. Right? That's there. Okay. Yeah, 1.6484. Okay. Now D. What's the error in that approximation? That is, what is the difference between your answer above and the best possible 4 decimal place approximation for e to the 0.5? Okay. So here, e to the 0.5, this after degree 5, there's no change, right? After degree 5, there's no change. You see that? That's why here, this is the best one for less than or equal to 4, right? If we had no change here, no change here, no change here, then the best would be 3, would be degree 3. But it gets better until it starts to not change. Okay, so that's why that one we chose there. But the best approximation happens there. And then after that, there's no change. So the error in this is the difference. Is how much further do you have to go, or how much more closer to the actual answer is that, right? And so the answer here is 1.6487 minus 1.6484. Right now, if you put this into WebAssign, that won't be the right answer. They're going to want what this is equal to. But let's see. If you just subtracted those, right, this would be 0.0003. We can even do that. 1.6484 subtract, right? You get a 3 there. 0, 0, 0, 0. There we go. All right. Old school.